Why do so many people procrastinate? And why does a looming deadline suddenly help people stop procrastinating? To understand procrastination, you have to understand motivation. Motivation is made up of three components: goals, emotions, and self-efficacy. Goals are the short or long-term outcomes that you want. Emotions are how you feel about the goals, and how you feel about the goals depends on how important that goal is to you. Together, goals and emotions determine how much we value an outcome. Next is self-efficacy, also called expectancy. This is how much you believe in your ability to reach a goal. So if you think there's a 90% chance of succeeding and a 10% chance of failing, then your expectancy is 0.9. We can now rewrite motivation as equaling how much we value an outcome and our perceived chance of reaching that outcome. Motivation equals expectancy times value. We can use this formula to figure out our expected payoff. Let's say we value something at $1,000. As expectancy changes, our expected payoff changes as well. On one extreme, we have an expectancy of 0%. This is something that is impossible for you to do. If I offered you $1,000 to jump over an entire building, then how much would that offer be worth to you? Since it's impossible, the perceived value of the offer would be 0. On the other end of the extreme is complete certainty. Here, the perceived value of the offer is the same as the objective value, $1,000. In the middle, the perceived value depends on how likely you are to succeed. A 90% chance of success would be valued at $900, while a 25% chance of success would be valued at $250. But if motivation equals expectancy times value, then why do we suddenly stop procrastinating when a deadline is getting close? The value of turning in a paper or completing a project doesn't change as the deadline approaches. And expectancy would either stay the same or decrease, meaning our motivation should go down, not up. The problem is that this equation assumes that the reward happens at the same time as the action. When there's a lag time between an action and receiving a reward, then you have to adjust the formula to account for time. Because let's be honest, we don't just want the highest reward possible, we want that reward now. So we need to alter our formula to account for delayed gratification. To do this, we take the number we got earlier, our perceived payoff, and we divide it by 1 plus impulsiveness times delay. Delay is how long it takes before you receive your reward. Since we'd rather have rewards now instead of later, smaller delays are better. Impulsiveness is how sensitive you are to delays. A patient person is going to be less affected by a delay than an impulsive one. So lower impulsiveness means that delays don't affect you as much. So let's look at how motivation changes as a deadline approaches. For simplicity, we're going to assume that the value of what we're doing and our percentage chance of success doesn't change throughout this project. No new information changes how important finishing our project is or how likely we think we are to succeed. Let's say that finishing a paper and turning it in on time is worth $200 to us, and there's a 90% chance that we're going to succeed. So our expected value is $180. Impulsiveness is a constant. People that are patient are going to stay patient, and people that are impulsive will stay impulsive. To make things simple, we'll say that our impulsiveness equals 1. As delay increases, we divide our expected value by a larger and larger number, so motivation decreases. Putting the numbers in, we find our motivation is given by the line y equals 180 divided by 1 plus x. This is how our motivation changes over time. On the far right, motivation is really low, and it remains low until the deadline gets fairly close. There isn't a significant rise in motivation until near the end. So this graph tells us how motivated we are at any given time, but it won't tell us when we'll stop procrastinating, at least not yet. To figure this out, we need to compare our motivation to write our paper with our motivation to do something else, an avoidance activity. Instead of writing the paper, let's say that we'd rather be playing basketball. First, we need to calculate our motivation for playing basketball. Let's say we enjoy basketball at around $20 per hour. If your boss calls you and asks you to voluntarily come into work and they offer you less than $20 an hour, you're going to say no. Anything more than $20 an hour, and you'll say yes. Since playing basketball doesn't require any delayed gratification, impulsiveness and delay multiply together to equal 0. Using the motivation model, we can fill in the numbers like this, where motivation is equal to 1 times $20 divided by 1 plus 0. Motivation equals $20. This line is represented by y equals $20. So given how much we value each activity, when are we going to stop procrastinating and start working on our paper? Well, to find out, we simply need to solve for the intersection of the two equations. You'll stop desiring to play basketball when your basketball equation and your writing a paper equation are equal. When 20 is equal to 180 divided by 1 plus x, or when x is equal to 8. 8 days before your paper is due is when your motivation to write your paper and your motivation to play basketball are the same. So procrastination is the result of two different forces. The first is the low motivation that we feel when the reward is far off. The second is the steady motivation of avoidance activities. So even though we value getting a good grade on a paper, finishing a project, or starting a diet, the delayed gratification often lowers motivation below avoidance.